session, of course, like all the other sessions as well, but as briefly indicated this morning, to actually make this operational, there will be a lot of tricky things to be dealt with respect to the actual benchmarking, particularly also the security aspects and also the legal aspects. And so we have 4 speakers now in this session. So we have Christian Tscheffal and Alina Wernick. They're lawyers, researchers at the Alexander von Humboldt Institute for Internet and Society in Germany. They will begin. Then we will go to Giovanni Cherubin, who's a postdoc here with Professor Troncoso at the EPFL. And then we have Professor Jean-Pierre Hubo, also at EPFL, who will also talk along the lines of security. And then we'll have the panel, which I think should be very interesting. Everything you ever wanted to know about security and legal aspects about AI. So without further ado, then I would ask the first speaker on stage. This is going automatic. I still give you this.
Thank you. Hello, everyone. My name is Christian Tscheffal. I'm very pleased to be here. Thank you so much for the invitation and the challenge, because it is a challenge to be the first speaker after lunch, and also to give you an overview about the legal topics in a way that is interesting for you, and also hopefully shows you what the law and legal aspects of this project entail. And therefore, my colleague Alina Wernick and I decided that I would cover some broad aspects to give you just an idea that law is more than just a regulation and a limit on the great idea and the things you plan to do. And Alina will then highlight some legal questions specifically in the project. And what I would like to do, so my broad metaphor is rather a different layers of the law, so not layers of a neural network, but layers of the law. And I would like to tell you that law can be a limitation in certain fields, but it can also be a motivation, especially for policymakers looking at the project you're doing, and it can impact the design process and the whole process of building applications very much, I think, to the advantage of this focus group. So I'm starting with the motivation, and I think the ITU has shown in the AI AI for Good context that AI actually contributes to achieving sustainable development goals, health being one of them. And what I would like to tell you is that the law might motivate and even oblige people to employ AI solutions because it's state of the art, or there are other obligations that motivate this. And I think it's important when you start out to think about that there's also this background. I just brought you a lot of specific rules, but I will just explain them to you, so you don't need to read all, just for you to know that I'm not telling you marvels, but it is in the law. There is a right to health in the International Covenant on Economic, Social and Cultural Rights, and it entails the creation of conditions which would assure all medical service and all medical attention in the event of sickness. So for everybody in the world, this is a universal human right. And we have a very interesting technology clause in a very new human rights treaty, Convention on the Rights of Persons with Disabilities, which actually pushes for the promotion and development and research of new technologies. So this is, of course, at a high level, but it's important to know that it's there. And another motivation that is more focused on e-health. I will come to other things as well. But at the moment, in different countries all over the world, there is an increasing there are regulatory efforts for cybersecurity, and this has resulted in actual laws that require cybersecurity for all connected devices. And what I think is interesting here is that these state-of-the-art obligations could also call for testing and validation in the development process. And to give you just one brief example, I think one of the speakers will elaborate on AI and cybersecurity afterwards. But there are these poisoning attacks where different parts of AI applications are changed in order to for them to malfunction. And I recently read in 2 threat reports that they are now really commercially in the darknet, commercially available. So you can order poisoning attacks for algorithms, and it might be that there is a state-of-the-art requirement to do testing and validation. To come back what Professor Salati said this morning, I think this could be a reason to strike out terms and conditions which go against benchmarking in certain respects, calling for testing and validation. So this was the motivation part, but law is, of course, as you all know, often a limit. So you want to do something and the lawyer comes and says, well, we have this problem with data protection or cybersecurity law. And just to tell you that this is, I think, very important because law voices societal concerns. Law is actually also a medium for learning these things. And one problem we have, especially in this context, I'm also a trained international lawyer, so I can tell you there is a big fragmentation, especially in the field of technology in the moment. There are solutions to that, for example, for data protection, but it's quite tricky when there are competing obligations. So Switzerland had it with the United States and banking law. There is an obligation to disclose and an obligation not to disclose. In Switzerland, not to disclose. In the United States, to disclose. What do you do? And we see that. I give you just two examples from recent regulation in Russia. It's now forbidden to, there's an obligation to store data within the Russian Federation, which has been a problem for many applications. And it can be solved in some circumstances, but this is definitely a challenge. Another challenge is expected in the United States, where there is export restrictions on technologies. This is at the moment just a proposal, but it is a proposal for export controls on emerging technologies. But it is expected that some of the examples I mentioned to you, like neural networks and deep learning, reinforcement learning, computer vision, are then under export control, which means an algorithm that would be provided to the test environment would firstly need to go through this export restriction. And on the other hand, there is ways. So we have different laws in different countries, which make it very difficult to work together. I just want to highlight that there are, of course, mechanisms for collaboration. I gave you examples in the General Data Protection Directive of the European Union, just to give you some examples how European data protection allows collaboration, for example, binding corporate rules within an enterprise, or adequacy decisions for countries, certifications, or standard contract clauses that are approved by the data protection authorities. So different mechanisms to deal with the problem that we have different jurisdictions, each of which imposes its rules. And I think this will be very interesting to follow up in this focus group. But I found many other solutions. Just one from Japan, where they had a policy on how to recognize clinical data. a checklist and also an explanation how this can be done. I think it's not. I think it's not outdated, but it might need some updates to employ it one-to-one. But there's a lot of interesting information in there that also shows how you can work together. And so I briefly mentioned motivation, the limitation function of the law. And now my last point really before I hand over to Alina is the design function. And I think the law can assist in structuring and influencing the design process. And this could be, I think, very interesting and important when you look at what could happen with what you are producing here, because more and more there are obligations how to structure the design process of any IT application. And the most well-known example is a rule also in data protection by design, and cybersecurity by design. It's Article 25, and I will not read everything, but just translate to you that it is required of computer scientists, programmers, and people responsible for the data to think about the goals of data protection and cybersecurity while setting up the systems. So the law reinforces, in a way, you could say the goal function of the whole project, because it adds this goal of data protection. One thing, I was really happy that we had this conversation this morning about fairness, because I know this from my own personal work in a standards committee on algorithmic bias considerations. This is a very, very important topic in many domains of AI applications, but it's also very hard to agree on what fairness actually is and how to deal with these projects. And I refer to one of the people asking questions and a little bit saying that it's very difficult nearly impossible to have an unbiased solution in many settings. So you need to handle biases in many respects. And I think there is also a lot to be learned from the law, because you have processes either negotiating or deciding upon questions of fairness based in basic rights, but also equality law. So this is also a topic which I think will be very, very important. And what's also interesting, so this is a very remote article that does not apply to the project, but there is more and more definitions about how validation actually works. And I brought you a section on the validation and testing of risk management system for text algorithms, which is remote. You don't need to read it, but I think that there is a growing awareness also for regulators that testing and validation is going on. And I think the things I've already learned here today, and reading all the document, I found many things that I could feed into the legal discourse, and I think legal regulators can learn from, because they will have to deal with these questions. So the law learns from this project, but this project also has to deal with some legal questions, and the legal questions involved will be dealt with by my colleague. Thank you for your attention.
So it's an honor to be here, and the purpose of this focus group is extremely important. And I'm glad now to highlight some legal questions that many have already popped during the conversation, and hopefully we can now look at them in a maybe more systematic manner in 10 minutes. So I seek to provide a bit of an overview of the parts I will focus on, and mostly I will look at the legal nature of inputs that you need to create a benchmarking data set, how they can be submitted into the project, and also what are kind of the big open questions related to legal issues. At this point, I sometimes feel I have more questions about the project than answers, but we can then think about them together. And then if we have time, I'm working in a project at HEEC focusing on telemedicine, so we can look a bit what are the legal questions related to AI-driven telemedicine applications. So in terms of overview, Christian provided a very broad perspective on what law plays in this focus group. I will look more into the inputs that we need to machinate benchmarking process, their transfer. The actual benchmarking framework, I think at this point, it's still a bit under construction, so it's very hard to say in a kind of precise fashion what would be the different obligations of actor, what kind of processes you should establish. So I think that's maybe something we will be discussing then in the future. As for benchmarking process, there's one question related to the protection of artificial intelligences which are being tested. And then finally, there's the evaluated AI as an output, which kind of has its own legal ramification. For relevant legal inputs, just a side note, I focus mostly on the European/German situation. So if the legal situation is very, very different in your country, actually I'm very happy to then hear about it. But we're mostly dealing with personal data. And under GDPR, so General Data Protection Regulation, it includes also pseudonymized data. And specifically for this project, it's important to know that we're dealing, when I look at the user cases, we're dealing mostly with health data, biometric data, when we talk about retina, and possibly in the future genetic data. And they're regulated as a special category of data, which enjoys them more protection and is subject to fewer exceptions, which it's good to take into consideration when designing a benchmarking process. Again, on the other hand, if the data is anonymized, it's no longer treated as personal data, so there's less precautions to be taken. However, as you well know, there is data which is not necessarily subject to any legal form of protection, but it's still in the ownership or some actor holds it and controls access to it, and then de facto can decide who can access the data on what terms and at what price. And then in the user cases, open data sets were mentioned, and I'm not always sure what you mean by them, because it could be just data available anywhere, or it could be data available still according to certain contractual conditions, and maybe this will be more clear than in the future, but I just wanted to flag that. Finally, data can be a trade secret if it creates a competitive advantage on the basis of being secret. And I don't know, possibly this can be something to be taken into account, especially when designing the confidential data set. And finally, I saw from the use cases that there's also intellectual property rights involved. So photos, if they reach the threshold of being author's intellectual creation, maybe some of mistake photos they're protected by copyright. In addition, in some countries, including Germany, photos which do not qualify as an artistic work still enjoy protection under neighboring right. And finally, in Europe, there also exists protection for databases. And this is not copyright protection, so I doubt there will be databases which are created with a big artistic intent in this context, but this database right is a special form of protection which protects the investment into the creation of database. So that's again another form of input which special level or special quality of protection in this project. And how could they be submitted into the data set or into the benchmarking framework? So in very, very general terms, processing of health, genetic and biometric data, main rule is that you need to have explicit consent for specified purposes. There are exceptions for public interest, public health, scientific research. These exceptions in GDPR haven't really been drafted with an idea of, okay, there will be a standardization effort for an AI for health. So it needs some reading, whether then these exceptions which are in national legislation fit this specific initiative. On the level of GDPR, it did appear to me that the scientific research can be understood in wide terms, but it depends on the national then implementation of these exceptions. For cross-border transfer, Christian already covered this topic. I will just add that beside these safeguards, there's also an exception to them, which is, again, if the data subject gives an explicit consent for transferring their data to another country with no equivalent protection as GDPR, then it's valid. And for this other type of input, for de facto controlled data, it's mostly contractual conditions which define it. For trade secrets, again, contractual conditions plus you need to keep them secret. And then for intellectual property rights, it's mostly licenses. I think in some forms there might be a collective management, rights management society which could facilitate the transfer, so you don't need to get rights from every individual who took a photo, hopefully. And then there are also some exceptions. So there's a discussion, for example, to introduce in Europe a data mining exception in copyright. This, again, the exception weren't really tailored so well for this initiative, so it's hard to say whether they really facilitate this project. So I would say that license is a primary way to get access to intellectual property rights. And then to open questions. So I already mentioned that the role of exceptions is, since they're often drafted on the level of national legislation, there are differences between them. So one should then check from the country which is in question, or where this benchmarking framework will be operating, from in which country you're going to take the inputs, what exceptions are in place. And generally, one should, throughout the process, account for the differences in national legislation. And again, Christian talked about the data protection by design and cybersecurity by design. I would also add to this confidentiality protection of possibly trade secrets, and as well as intellectual property right protection by design as something which can be considered in quite early stage of developing a benchmarking standard. And two other things that came into my mind just as a conversation. When combining data set, it might be wise to kind of look into contractual conditions and make sure that you can combine the data sets, you can keep the data for as long as you need, and just that they really support the intended uses that you need for them. For example, in open source software, maybe some of you are aware that some licenses are not very well compatible with each other, so one wouldn't want to have that type of scenarios, which are not necessary here. And then one thing is competition. I saw already in the data submission outline, you had some discussion on how to take into consideration that some actors might be competitors and who should submit data. And I think this is a really good consideration. I think this whole initiative is really pro-competitive because you're trying to allow different AIs to compete by merits. And it's good to keep in mind in the process that you, beside being fair, you also avoid a competitive bias so that the standard wouldn't favor any specific actor from the perspective of competition, but would really set them on an equal level to show how good they are in diagnosing diseases, for example. And now, quickly to telemedicine, so possible output of benchmarked technologies. I will talk very shortly on business to consumer application. So they also deal with health, genetic, and biometric data. And for these purposes, GDPR has a bit more exceptions. So, for example, there are exceptions in favor of diagnosing diseases and healthcare. But for other type of processing, the manufacturer, producer of this service or product, they would still need to obtain an explicit consent or they have an exception there in place or anonymized data. And also there are rules in GDPR on informing the data subject whether they are becoming subject to a decision which is made by automated process. And I just mentioned it there that it exists, but we don't go into details. And for liability, AI is likely to be treated similarly to software. And a funny thing about telemedical practices is that in Europe, there's a rule on strict product liability for defect products, but it doesn't apply to software. So we might be in a situation where you have a tracker which has a certain function, and if there's a defect, then you're liable without causation. But if it's just software, then you need to resort to national law on contractual liability and tort liability. So there are kind of curious differences in that area. And if a healthcare professional is involved in this application, it might also change the rules on liability which apply. And finally, I looked a little bit into the liability of standard setting organizations. So in a scenario where a standardized technology creates damage somewhere, can standard setting organization be held liable? Generally, the threshold is, at least in Europe, high. So there need to be some very obvious errors in the procedure. It needs to be very closed and not reflect the state in the art. So, yeah, it looks like this is completely different than the objectives in this group. And here only precaution is that if after the standard is already set, if you get report that or find out that it doesn't reflect the latest development of technology, or there's some reports in the field that it doesn't function as well as it should be withdrawn or revised fast. Yeah, so that's on that. Thank you.
So, this is kind of jumping ahead of ourselves. So, good afternoon, everyone. Thank you for inviting me here. I'm Giovanni Cherubin, a postdoc researcher in machine learning and security with the Spring Group with Carmela Troncoso. And today I'm going to talk about some attacks against machine learning models, or AI models, if you want more generally, about why we should care about these attacks, and about some ways we have for measuring the security of some model against these sort of attacks. So machine learning is getting more and more present in our lives every day, and we might even think that the major part of its applications are yet to be discovered. Now, particularly, this morning we have seen plenty of applications of machine learning and AI for health. So let me just summarize briefly without aiming to be any comprehensive whatsoever here. So we may want to use machine learning for predicting the risk for a patient to have some disease, or perhaps to have some negative event, such as a heart attack. But there's more and more attention in the use of machine learning for tailoring the treatment of some to individual patients. So, for example, we may want to customize the drug dosage to patients. And overall, we might say that AI methods and machine learning models allow us to improve our decision-making abilities based on historical data. So the setting I will consider for this presentation will be as follows. So we will suppose we have some data, possibly coming from different sources, and we'll collect this data to construct some machine learning model. Now, this is much simpler than it looks like, but I believe Jean-Pierre in the next presentation will talk about part of this process. Now, suppose that we have this machine learning model. Now, ideally, what we would like to do, at least for the purpose of this presentation, is to allow some users, say some patients or some doctors, to ask queries to this model and to get back some predictions. And these predictions could take the form you have seen above. So why is machine learning the right tool for this kind of problems? Well, to state this simply, machine learning is very good at modeling patterns, and at modeling patterns that are more and more complex. And of course, we are interested in machine learning because it can automate all this process, thereby reducing costs, but also because it allows us to scale to a much larger user base, to more and more data if we wish. So how can things go wrong? I'm giving a security talk, so some things must go wrong, unfortunately. So let me state a particular instance, a particular setting under which we will work. So we suppose we have some private data on the basis of which we train this machine learning model. And the idea is that we want to allow users to query this model with some of their data. Suppose here this model takes as input the age, height, and so on and so forth. And the idea is that this model should return two things. It should return a prediction, which could be, oh, this person is likely to develop this particular disease, and some confidence. Now, this confidence is very important here because it indicates how credible the model, how confident the model is about the prediction. Now, of course, this is a form of credibility for us, for the prediction, and we would like to keep this. But as it turns out, this confidence level carries a lot of information, and it carries a lot of information about the private data, which we don't want to see leaked. So let me give you two examples of attacks that are based on this idea. So the first one by Chokri et al. Is called membership inference, and here the goal of the adversary is to predict whether some users the data of some particular user was used for training the model. So this is how it works. We suppose the adversary is some malicious user. It could be a malicious patient, and this adversary has knowledge of the data records of some particular user. Now, these data records could be accessible via many means. It could be from Facebook rather than some other data leakage. But what the adversary wants to know is whether this data was actually part of the private data of the model. Now, how can he do that? Well, Chokri et al. Showed that whenever the model is overly confident about its predictions, somehow it's saying that, oh, I've already seen this particular data point. It was in my training data. And therefore, the adversary, the attacker, is able to predict that this particular that the data of this particular user was in the private training set. Now, let me give you a second example, which has a kind of similar setting. Now, this time, the model accepts as input some parameters, some of which are known by the adversary, say they can be easily guessed, but some other parameters, so say just one in this case, is particularly private for that user and is not known by the adversary. So in this case, this parameter is HIV, indicating whether the user has or not this. Now, the goal of the adversary in this case is to predict whether this user actually, whose data was used for generating the model, I was saying whether this user has a HIV or not. So how can he do that? Well, Fredrickson et al. In 2015 showed that what an adversary should do is query the model for all the possible values of this parameter. So say for HIV equal to false and for HIV equal to true. And once again, just by looking at how confident the model is about its prediction, the adversary will very likely predict the correct value of that attribute. So in this case, it will infer that the user has HIV. So all these attacks, and hopefully this will be one of the takeaways, all machine learning models tend to reveal some information about the private data on which they are trained. So what can we do about this? Well, we would like ideally to measure the security or to measure this quantity of information that is revealed by the models. And of course, we would like to do this before we actually deploy these models. But also, we would like to do this without having to understand exactly what's happening inside this black box that is the machine learning model. And that's because sometimes it is too complicated to formulate, to express this in mathematical terms. But still, we would also like to have some formal guarantees. If we say this model is this secure, we would like that to be some kind of a precise security measure. And well, as it turns out, there's a whole set of tools that allow us to do this. And these tools have kind of a long history, although there has been fairly recent developments about them. So I'm just going to give you an idea of how we would proceed for measuring the security of a model in practice, and I leave out the technical details for questions afterwards at the pub. So suppose we have this machine learning model, and it's been trained on private data. Well, the basic idea is we, as security analysts, we want to query this model many times and get back the respective confidence levels. And we want to do this, again, many times. It could be a few thousands of times. And now it was shown that just from this data, and therefore thanks to this black box approach, meaning that we don't really know what's happening inside the box, just from this data, we will be able to estimate somehow some kind of security, and that is effectively the likelihood that some attacker succeeds in this attack. Another way to see it is we are measuring how much information is being revealed by this model with regards to the private data. So Now, before I conclude, I wanted to point out a whole different class of attacks, which do not follow the same threat model considered so far. So until now, we thought, well, the attacker will be some possible malicious user. But then, what if the adversary actually could input some data which is used for training the model? And this was actually mentioned in the previous presentations this afternoon. This is usually referred to as adversarial poisoning, because an adversary now can provide some malicious data to somehow control the model and make it misbehave, possibly. So this falls under the umbrella of adversarial learning attacks. And this is also some of the problems we're working on at the Spring Lab. So just in conclusion, well, machine learning models, and hopefully this is the major takeaway, do reveal information about the data on which they are trained, on which they are constructed. And before releasing them, we must measure how much of this information is actually kept. And black box security techniques allow to do this. I haven't spoken about the details, but they are allowed to tackle these kind of problems. Also, today I've heard several times talking about fairness of machine learning algorithms. Well, as it turns out, membership inference attack, the attack I presented before, and fairness are two different concepts, but based on very similar principles. And we believe that some of these problems, such as fairness, could be also tackled using these techniques. And of course, I've pointed out that there's more. There's adversarial learning problems when the adversary actually can tamper with the model itself. And I believe there's also with regards to training the model itself, and that's why we have the next presentation, I believe. So thanks a lot for listening, and I'll put this online somewhere. So thank you.
Good afternoon. Voilà. Let me just, voilà, thank you very much. Thanks for inviting me. What I'm going to mention today is a follow-up of what those of you who were in New York in December have heard from Jean-Louis, who happens to be former PhD student in my group, and he is in the room over there. Yeah. And is now working with CHUV, with the main hospital in Lausanne. So I'm going to talk about secure and privacy-preserving data sharing for artificial intelligence in health. One reason to address this topic is that, unfortunately, very unfortunately, the medical sector is under attack. More and more medical data breaches, and the magnitude of the problem has become such that at the time at which there was still a federal government in the US, they have set up a website where they report, it's an official website, it's a very, I think, useful resource, where all the attacks affecting more than 500 people are reported in the medical sector. And as you can check, there are around 5 declared breaches per week. Right? Sometimes it's tens of thousands of people who are affected, sometimes it's hundreds of thousands, sometimes it's millions, or if not tens of millions. So this is something that has to be taken into account by this group, the fact that there is the medical data, health data have value, and therefore they are targeted by the organized crime. Now, fortunately, there exist a number of technologies for privacy and security protection. So let me mention some of them. So traditional encryption that provides protection of data at rest and in transit, but they cannot protect data while they are being computed. Homomorphic encryption that does protect computation in an untrusted environment, but has its efficiency issues. Secure multi-party computation that protects computation in distributed environments. And then, so these are, let's say, the three families are usually implemented in software. There are also hardware-based solutions. The ones that the so-called trusted execution environment that are very efficient usually, but do require trust in the manufacturer. Right. Differential privacy is something that was indirectly hinted to by the previous speaker. The ability to measure to what extent data leaks information and therefore to set up countermeasures. And then the unavoidable blockchains that I'm sure have been, let's say, are known to most of you. So blockchains, I'm not willing to talk too much. I'm going to just mention them briefly because they are not really the most important thing. Homomorphic encryption. How many of you know vaguely, at least, how this works? Please raise your hand proudly. Okay, quite a few. That's great to hear because I think this is typically the kind of tool that can be useful for this community. So homomorphic encryption is something that is very convenient, at least at first sight, because it allows to either compute and then encrypt or encrypt and then compute. So, and this is something that has been known for decades in cryptography. It means that, for example, you can encrypt your data as a user of the cloud under your own key, store the data in the cloud, let the cloud make computations only on encrypted data, so without ever seeing the data in clear text, and provide you with an encrypted version of the result, and you are the only one as a user to be able to see this result. So it's a kind of wonderful tool. Unfortunately, it's pretty heavy, and there's been a lot of research on this topic, and now really operational solutions are becoming available. So now back to the slide that Marcel Sarté showed this morning. So this is, let's say, pipeline that is meant to be developed. So as we look at this as a security specialist, you say, there are multiple ways to attack this stuff, right? So where is the best place? So here is the attacker, and well, let me just mention, for example, well, check the test data, but it could also be elsewhere, or as mentioned by the previous speaker, by Kerubin, well, just try to infer data from the outcomes of the computations. There are many possible attacks that have to be anticipated. We should not be naive, right? So we know that things are going to go wrong, right? Well, now we know. Right? Now we know. We cannot say, no. We know, notably from the internet, right? Things are going to go wrong. So we have to anticipate this and see what can be done according to this. So one way to bring data protection in this framework is to make use of a concept that is called a collective authority. And I think Jean-Louis already presented this in the previous meeting. So the idea here is that there are a certain number of authorities or stakeholders that are entrusted, for example, the ITU and the WHO and for EPFL, for example, but it can be any, let's say, a reputable institution that is in charge of running one node of something is called a authority. Authority is something that is coined by my colleague Brian Ford, because we're working a lot with their tools. Brian Ford is a colleague also in CS, like me at EPFL. And so this makes it possible to have a shared key that that relies on the trustworthiness of all the institutions involved in such a setting. And then there is a permissioned distributed ledger or blockchain that keeps track of the transactions whenever this is required. So in this way, trust is distributed within the collective authority, which means there is no single point of trust or failure. And then the test data confidentiality is provided by end-to-end with collective homomorphic encryption. And then the accountability and transparency is provided by the blockchain. Right? Voilà. So working along these lines, there's this project called DPPH, Data Protection in Personalized Health, that brings together specialists of a very diverse domains, an ethicist at ETH in Zurich, the Swiss Data Science Center, they aim at machine learning solutions developed at national scale, if not beyond, a geneticist, Jacques Fellet, Dimitar Yetchev, a mathematician who does crypto, the previously mentioned Brian Ford, and myself. So this project is actually aiming at being the project in charge of data protection in the nationwide or Swiss-wide endeavor called the Swiss Personalized Health Network. So the project has been running for 9 months, and it addresses the main, let's say, the goals of privacy, security, scalability, and ethical challenges. And so we talk extensively with hospitals, but also a little bit with the pharma to find the best trade-offs and the best solutions to be deployed in this framework. So the long-term vision is the following. So there's here one researcher who is willing to make a request. And so this request will leverage on the data that are actually stored in various places. So this is somewhat, let's say, Helvetocentric perception of the world, but we have to start somewhere, right? So with Lausanne, Geneva, Lausanne, Bern, Zurich, Basel, Zurich, sorry, and so on. And the idea is to provide the ability to generate requests to this, let's say, to data that are distributed across these various medical institutions, right? For example, question 1, how many patients with BRCA1 and breast cancer? Question 2, what is the survival rate for cancer patients undergoing a given chemotherapy, and so on and so forth, right? So this is as mentioned, what is happening at the Swiss level. Now, in Switzerland, we are aware of the fact that there exist human beings also beyond our borders. And so there is something that is called the GA4GH, the Global Alliance for Genomics and Health, that aims at doing similar things at a broader scale. How many of you have already heard about the GA4GH? Please raise your hand proudly. Voila, maybe 4 or 5. This is the usual beautiful balkanization of the health system where people do different things in different frameworks without talking too much with each other. This is surprising to me because I'm coming from telecom where people are from ITU. I'm almost an ITU. I'm part of the ITU family. So I would recommend to talk with these people who have, because they have really thought about how to share data at scale. And the GA4GH has its own work stream on data security. There are, white papers, recommendations, and so on that can be reused in the framework, I think, of this focus group. Now, there's something called Drynx. So this is a tool that we have developed in my group, and that this tool enables computations on federated databases while protecting individuals' privacy and data confidentiality. So the idea here is to be able to make requests a la SQL, so the database stuff, right? And then to make operations such as linear regression or logistic regression, which are trivial operations, but they are carried out in a decentralized way in a homomorphic space, which makes things a bit more complicated. And the adversaries can be malicious, which means that it can be proactive adversaries and not just adversaries that are listening, right? So for example, let me show you quickly how linear regression query would work. Let me introduce the main characters. What you have here are the data providers, or these are, for example, hospitals. Here you have the computation nodes, right, that are, on which actually the computations themselves are carried out. Here are the verification node that make sure that no poisoning, for example, has taken place and that the results are legitimate and correct and trustworthy. And here is a querier, the researcher that we have seen previously, who is willing to ask a question. And for example, select a linear regression on blood pressure, heartbeat, blah, 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 cholesterol, where the patient age is between 50 and 90, right? For example, right? Then then this is going to be, we want to, for example, so we are here to compute the linear regression. So we assume a data set is read over the data providers with D features x1 to D1 to xd, and then a label value such that we want y to be approximately equal to C0 plus blah, 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 right? And so on. So here, maybe I'll spare you the technicalities for the sake of time, but let's say these are the kind of computations that are carried out, and then those data are summed by the computation nodes, and then this is going to be expressed as the product of this matrix and this vector that has to be approximately equal to this other vector, and in this way we'll indeed make the expected computation, right? So now this is about linear regression. We can also carry out logistic regression. There are tricks to do this in homomorphic space. And of course, the next step will be, well, neural networks, right? So to carry this kind of operations in distributed homomorphic space, let's say, including operations that are, let's say, of the family of neural networks. And we are currently working on this topic. So I hope that in Shanghai it will be possible to provide you with more information on that. Okay, and then we have, from Drynx, we have derived a tool called MedCo that is customized, a kind of customized Drynx specifically for health, with a secure outsourcing that is, I mean, again, enabled by collective encryption of the data, end-to-end data protection through homomorphic encryption, and compliance with the previously mentioned GDPR. Right. So this is something that really tailored for that purpose, and we have a paper that is already online on this, and we are going to make an announcement about MedCo in 10 days from now, roughly, revealing the whole source code and making a bit of a buzz. So expect some tweets around this. Voilà. So this now, one of the strengths of MedCo is that it leverages on tools that some of the biometric researchers are very comfortable with, including I2B2. How many of you are somewhat familiar with I2B2? Raise your hand proudly. Voila, 2 out of 3 out of 50 or 40. Okay, that's modest, but so I2B2 is essentially a tool that is meant to facilitate the exploration of patient cohorts, and is more widespread in the US than here. Voilà. Now, let me also mention that there exists a number of events on genome privacy and security, and I would really encourage this group, this focus group, to look at everything that is happening on the front of personalized medicine, all the omics, because this is where the most crucial challenges, probably the most beautiful opportunities for applications of machine learning, but also the most challenging issues vis-à-vis data protection, right? Because omics data is by essence identifying data, so it cannot be anonymized in practice. So let me just mention here all these pointers. We also maintain a website in my group, genomeprivacy.org, where we keep track of everything that is happening in the world, which means primarily US and a few other countries on this topic. Voilà. Let me conclude. So worldwide, the confidentiality of health data is in jeopardy. There is no question about this. The standardization and regulation of AI in health can only be achieved if people trust the whole process to be safe, secure, and fair. You have to reassure people about what you are doing, especially if you combine health data with ML, right? Now, the good news, I believe, is that advanced privacy-enhancing technologies, such as the ones that I've mentioned, can be effective enablers to achieve the goals of the FGAI4H, right? And I believe that synergy has to be explored between FGAI4H and GA4GH. Well, and so and here are let's say, the websites of the tools we are currently working on and of the project. Okay, thanks for your attention.
And if you could have a running mic. Good. So before we can take questions, so please raise your hand if you have questions. Before we take questions, so quick question to you, Jean-Pierre. So you said a couple of months. So in a couple of months we have homomorphic encryption for neural networks. Is that the promise?
We'll see. I mean, clearly there is a tremendous expectation in the field.
Yes.
And the one has to be careful, right? This is, let's say, the kind of things we are working on. We are certainly not the only ones. And one has to be very, very careful because it's not binary, right? In the sense that depending on the adversary you consider, depending on the level of decentralization, depending on the sophistication of the neural networks, and so on and so forth, one has to say. So some of the things are going to work, some other things are not going to work. One has to be very, very careful in qualifying the claims. But I think that even, for example, with, let's say, linear regression, logistic regression, one can do a lot of things, right, in terms of what is happening in health. I mean, I look at what is done by most of the biomed researchers. It very often boils down to that. So if already that can be done in a way that is systematic and that is that avoids all the bureaucracy and all the the month-long discussions between lawyers of different, for example, hospitals to agree on something. Just have a framework and say, okay, there are these tools, they're reliable, they can be used with a kind of technical framework. With the blessing of lawyers, it will be a tremendous step forward.
All right, questions? And remote, obviously, feel free to ask questions.
Okay, I guess I'll ask the first question. I guess the question is for Giovanni more than anybody else because his presentation revealed these attacks that allow people to do a query and reveal private data. That was really interesting. I didn't know about it. But it brought up this point which I had in my mind that, when you do a benchmark of an AI model, the way you measure how good the model is how confident it is about making a prediction on unseen data. So, the more generalizable the model is, the better its confidence, right? So that kind of goes against, so I'm trying to understand, that seems to be in conflict with what you've stated about the fact that if you have a high confidence level, unless the model is overfitting, which case it'll obviously, if the model had that particular data point within the training data, obviously it's going to have a high confidence level. But it's also going to have a high confidence level if the model is actually good, it hasn't seen the data, correct? Am I right?
Yeah.
So I just wanted to understand how you resolve that.
Yeah. So the question, if I understand correctly, is mostly about the attacks. So yes, I agree with you. A big part of these attacks are because models are overfitted.
Right.
Of course, if a model is overfitting, it means it's remembering more about the data on which it was trained, and therefore it will reveal more information about such data. Unfortunately, it was shown that this is not always the case. So even if the model is not overfitted, these kind of attacks are still possible, just to a certain extent, clearly, but they're still possible. And I think there's a second note to make here, which is actually very interesting. So these kind of attacks are very nice for us because it's one of the rare cases where privacy and accuracy of machine learning go towards the same direction. So as you correctly pointed out, if we manage to train a model very well, so it doesn't overfit these things, then theoretically, or it will prevent these kind of attacks. So it's not privacy going against accuracy in this case, but rather than going in the same direction. But the main problem is how do we measure still if there is that kind of leakage, that kind of information leakage. Yes.
Okay, thank you.
Go ahead.
Thank you for these presentations. I have a question to Mr. Hubo concerning the nonlinear models and the homomorphic encryption. I asked this question already in New York, I think, and I was wondering to your colleague, I was wondering whether there are other possibilities then, because I understood, as far as I understand, the homomorphic encryption, it's only possible with linear models in any way. Not, I mean, the neural network in the end is also a linear model. It's highly linear, but I mean, so, and if you don't have something like this, if you don't rely on deep learning, if you have other models, however they are constructed, how could you make sure that this can also be encrypted and executed encrypted, or is it at the moment just not really possible and you should then use like trusted environments or whatever for that? Thanks.
So I think unavoidably we are going to have a world that goes exactly along the ways of what you are sketching, in the sense that for relatively simple computations, there's going to be a very strong level of protection. However, there are going to be limitations in terms of sophistications of the computation that can be carried out. Right? When very in-depth investigation has to be carried out on the data, probably at some point the researcher has to see the data, right? But then, you know, there is a continuum, right? There is probably first investigations that makes it possible to reach some conclusions, and then the number of potential researchers involved can be relatively broad, or it can be even the whole world. And then you restrict, you have to vet your researchers more and more. The more you allow them to carry out operations and get closer to the data. I think this is unavoidable. I think and in a way, to some extent, the world is already organized in this way, but with, let's say, protection techniques that are maybe a bit less sophisticated than homomorphic encryption. But you know, in some cases, what the data from even census data, you can have relatively broad census data that are made available to the whole population. But then to really have access to the data itself, people have to go in a specific room, they have to show ID, and they can do much more. So it will just reflect this kind of state of affairs. I do not believe in the fact that it will be possible to make any kind of non-predefined computation with a complete protection of the data. This would be let's say, something that is too ambitious. It's not realistic. Yeah.
There's a question there.
Yes. My name is Muhammad Noor. I'm from WHO, region of Eastern Mediterranean. Actually, my question is about the region, because our region is not that advanced, and I see that this security is getting more and more sophisticated. So is there a kind of maybe classification of advice for countries to have in their strategy a specific level of thinking ahead for their security of data? For example, I see that Russia has decided to have having the data specifically within the federal system, and the USA is saying that we shouldn't export some kind of technology. So what about the countries that are below this kind of level of sophistication? Is there a kind of advice for all of them to start something as a simple way of protecting themselves? Thanks.
There is actually, I think there is a process within the ITU focused on different regions in the world, establishing treaties or draft treaties that would enhance the cybersecurity policy for the respective states of the region. So this would be one thing you could refer to. And the other thing, would be maybe in the development context, there have been attempts to single out certain states and to help them to build a cybersecurity strategy. Especially, I know it for some African states, and I'll find the information on my computer. I don't have it on the top of my head, but with the view that mobile government, for example, is much more popular. So we have it in the e-government field, and I would need to check whether something has been done in the health sector. But I'm afraid if your organization doesn't know about it, then maybe there is maybe nothing health specific in that regard. But I know that there is for specific countries there are strategies in order to build up cyber hygiene and cyber security.
Can I put in a question? So you mentioned, I think it was you, that the legal situation for devices is very different than from software. So basically, as soon as you can touch something, it's under different legal constraints. Is that correct?
With regard to liability.
Liability, yeah. And so why is that? And or you'll put it different way, is that because once you have something you can actually touch and put away, that you have a record of that, and with software that is very hard? And the reason why I'm asking that is because obviously that comes back to what the focus group wants to do. If a given algorithm is evaluated on the 22nd of January 2019, how does anyone how will anyone be able to trust that algorithm in 2 weeks because it could have been completely tweaked?
Sorry, I didn't understand the reference to the date.
Well, it's just
so you mean like as an example that
you can change these things all the time, whereas if you put a product on the market, you can, as a regulatory, you can get this product or a couple of them and reevaluate them all the time, which of course we could in principle do with software, but I'm just wondering whether that's where that thinking comes from or whether it has nothing to do with it.
I think it reflects also general conservatism of a lawmaker. I mean, this directive, which set the strict product liability, was in the late 80s when it was enacted. So I think software or AI-based applications were really not on the table to be considered at that time. But I think part of your consideration are right, that it's more difficult to evaluate whether there was a defect from software than from hardware. My impression is that there are discussions of rethinking whether how to take it into consideration or whether to expand product liability to software, but at the moment it's not like that. And also, what you mentioned, I mean, what we didn't cover here is also the relevance of medical device regulation. And this is something which we will be looking in our project, but also that will be kind of a backup security for applications that are run by AI in health context. And it's not only this benchmarking process, it's ensuring it. Do you have something to add?
No, I completely agree with what you said. I think there are initiatives at the moment to look into software liability, as you mentioned, on the European level. Regarding medical devices, in many jurisdictions we see a very clear statement that software, before it was recognized already, but a very clear statement that software is recognized as a medical device, and increasing generative obligations on software. And I think this will have an impact on the liability, but not in the sense that you wouldn't need to prove causation. This was the big, or to prove fault, voluntariness, and this was the big difference that you needed to prove causation, which is very, very difficult with industrial products, but which is also very difficult. And I think there you're really right with software. So this could be something for the future to take into account as a problem on the horizon indeed. And I think there we are at the topic of transparency, and I think there's also a lot of competence, especially with Heinrich Hertz, Prof. Heinrich Hertz in the group. I think this is also a current to be strengthened just for this, for the matter of causation and these issues.
I would also add that when these benchmarking processes will be in place to be transparent of possible risks involved or possible margins of error also to those who use this benchmarking processes.
Mm-hmm. Okay. Other questions? There's a question there. We can go a bit over time because we started later. That's fine.
Okay. I just have a comment. My name is Benjamin Mutambi.
Thank you for your interesting talks. I have a question. You mentioned that it's different for pseudonymized data in comparison to anonymized data. So to my understanding, it's like I have some file and I give, and in the file there's a name, then I change the name to like subject 1 and it's pseudonymized. But what is anonymized? Because like sometimes it's not like in the file itself, but you can like by combining data you can recover the identity of persons, and nowadays this is even more given. So.
You're completely right in pointing that dilemma that technically it becomes more and more easy to de-anonymize. So I think from legal perspective, as long as you kind of do your best, what's technically feasible to anonymize, and you can't immediately available tools to re-identify the persons whose personal data it used to be, then it can be regarded as anonymous. And pseudonymized data means that you still have somewhere keys how to re-identify the people. And from data protection regulations perspective, it's generally recommended to pseudonymize, and it's perceived as one of the factors kind of suggesting your compliance with it.
Hi, can you hear me? This is Benjamin Mutambi. I'm connecting from New York. Can you hear me?
So I apologize if this partially already got answered and I just didn't understand because my level of base knowledge is not that high. But on this subject of, so I'm thinking about this and I'm thinking about my computer and my software, and I get on my computer and it tells me, hey, you need to download these updates. There are patches that come out for software when the software developer figures out that something's got wrong or it's vulnerable to attack. When you were saying before, Alina, about, well, the standard for being held liable, like if something turns out to be bad that you put out there in one of these models. So when I take that, it's pretty high, like it has to be whatever. So let's say this focus group puts out a series of benchmarks, okay? And then let's say some nasty adversaries come in and exploit some sort of vulnerability. Is there now, or do you foresee arising in the future situations where the nice focus group, which is trying to do a good thing by putting the benchmarks out there, becomes liable for keeping up the security of those benchmarks as hackers go at them?
I maybe some of you don't know me. I came late because the night trains are slow.
Weird.
I think what we can do is to have a transparent document, or what we plan to do is to have a transparent documentation of what we are doing. Have a transparent process, have a completely open way of documenting it, and then we would basically say this software module has this performance over that test set. So if you use a variation of that software model, and somebody wants to refer to our benchmark, then at least that portion should be the same For the other stuff, we don't make any statements. The way I view what we do from a liability perspective, I would say we are making more or less a statistical evaluation of algorithms based on data. And we document everything, and then that's there in place. And others can then make recommendation based on that. And as long as our documentation is rock solid, I think we are in the safe. And we are not, I don't think we are equipped to do regularization and regularization we actually are equipped to do, but regulation. For instance, we are not the one that buy the number of virus doses, right? We could just make an epidemiology prediction that somebody could say, I find that to be reliable. Here we go, I buy this many doses for this country. So this is how from our discussion point of view, where we think we should be positioning ourselves, but maybe our legal expert could then answer to that if that's the safest approach.
Two comments. So in terms of liability of standard setting organization, for what I read, and there wasn't so much immediately available. So one area was whether the procedure of setting a standard was open and sufficiently open, and whether key experts were involved, and these type of considerations play a role. And I mean, as long as it's recorded that these type of general established practices of setting a standard are obeyed, then that part should be covered, that it's not biased or it doesn't neglect some very important technical consideration. And as in this project, it's so important that this test data set is confidential and to maintain its integrity from the perspective of liability of standard setting organization. I mean, if you're not negligent with regard to maintaining sufficient cybersecurity of that file, then you should be safe. And for what I've heard here, this has been an intention or subject to intense discussion on how to do this, as it's a key also for the standard to be functional. So I hope this explained a bit of these two areas. Would you like to?
No, I can completely agree with you, but also with Professor Wiegand. I think regarding the cybersecurity, there is a state-of-the-art involved, and I think there was good reasons why we had two experts on the panel today. So, but this state-of-the-art is, of course, under, you would say, as a lawyer, an obligation of proportionality. So it's also depending on the actor acting. Government agency has to fulfill different standards than another actor. And I think this is important, especially when you couple it with what Professor Wiegand said, when you exactly state what you are doing and what you are promising to the people using it, promising not in the legal sense, but what is meant to do. Then of course there can be no more trust than you evoked, and then it's a question of negligence. So I think the issues of cybersecurity are to be taken seriously. I mean, we heard about the value of medical data, but it is completely clear that there is also a limit of what you can do.
One more question here.
Hello? It's not more of a question, but sort of just, I would say, comment. And I'm a technical person, by no means a lawyer. I guess the discussion broadly is about liability of the standard setting organization. That's what's being discussed. And by no means saying that the standard setting organization should be negligent, but looking at the sort of the display and the top two organizations listed up there, I do believe the UN PNI would come into play as well if sort of the worst was to come around, which is the United Nations Privileges and Immunities,
which sort of are a bit above the national laws which were being discussed? Just a throw a thought or question if somebody can react to it.
Thank you. I mean, I guess then maybe also more than anything, it's a fundamental Achilles heel of the focus group, I would say. I mean, if big consumer tech companies lose a bunch of data, that doesn't seem to put their entire existence into question. If the focus group loses, or if people get maliciously access to the very data with which there will be benchmarks, there is no more benchmark. And so the whole thing collapses. So, I mean, I think we have an extreme interest to have this at a maximum security, not just for legal reasons. It's always bad to lose someone else's data, but just we can basically all go home if that happens. All right, so I want to be mindful of the time. We have one more? Okay, we do one more. Still being mindful of the time.
Hello, can you hear us?
Yes.
I'm connecting from New York. I've been trying to chime in for quite a while. It seems like no one could hear me. Anyway, my question and comment is, I'm under the impression that we probably need to approach this at two levels in terms of data access. The idea of setting up this all-consuming repository to which data could be dumped, as several speakers have alluded, could be challenging. In some instances, where I am, for example, in the United States, the federal government actually has no authority to collect patient-level data from the clinical level. That data does get submitted at the registry level for those conditions that are reportable to each state, but each state retains that data and only submits de-identified, much more scaled down data to the federal government. Now that's the United States and its strangeness. I believe that this is not very different in many other countries. In fact, I come from South Africa, where patient level data isn't being collected electronically and submitted to the provincial government or to the national government. There are registries for reportable diseases. That's a bit different. That's not the data we need for this purpose. So I think there are other ways to work around this, though, where perhaps the goal of establishing this big repository could remain on the radar screen. But there are other things we can do that are less than that can in fact enable us to achieve our goals. There's a next level below the idea of a big repository, where in the modern information age, it's quite conceivable, and I've done this, I've worked at state government for 20 years, where I was able to create de-identified data sets, enter into legal agreements with various universities, take a data set, encrypt it and email it to them, but set up a workstation that could be accessed remotely, and they would be part of a collaboration team. So we would enter into an agreement for a collaboration team. That means there were no analysis that could be done on these remote access data sets that were not announced in advance and discussed and reviewed. But the analysis that's done could be retweaked and then resubmitted and redone on an ongoing basis until we have refined what we needed to accomplish. And it's quite conceivable to do that. So I think that secondary level where you could establish what could be considered to be a virtual repository with participating hospitals rather than necessarily governments. The government level can facilitate access to hospital level data. But in many instances, the government does not have what you would say is the equivalent of the UK's NHS, where you have this centralized, super centralized. That may be true in Europe, in the UK, but in many, many other countries where, in fact, the actual real world application of the data we're talking about still needs to be done does not exist. So that's my point. I would like to probably hear some feedback on whether that kind of two-level approach could be done for the project that we are proposing. In fact, we envisage doing that. We even believe that it's conceivable, having had prior discussions with our colleagues in the UK, that we would actually have access to NHS data that would be accessed by collaborating partners in our project who are based in the UK, who would have it on a workstation in their laboratory. And we would be able to collaboratively perform analysis that are needed without necessarily exporting the entire data set to some other unknown location. Thank you.
Thanks for your comment. There's a response from Jean-Pierre Rigaud.
Yeah, so thanks for bringing up the example of one federal country, which is the US. Another example is Switzerland, which is also federal. So similar phenomenon, maybe at a slightly different scale. There are in Switzerland 5 university hospitals. Each of them prefers to keep its own data for its own, but is willing to share. By sharing without letting the data out, which means that we have to bring the computations to the data and not the data to the computation. And the kind of toolset that I described previously achieves exactly that. And for this reason, we also talk a lot with your colleagues in the US because indeed the NHS solution is maybe appropriate for the UK example in specific cases, but it's clearly not scalable at a broader scale, and it is probably not acceptable at a fully international scale. So some level of decentralization has brought to the picture.
Thank you. So now we really need to end it, unfortunately, but this could be very interesting. So just to close it, I'm going to put one question to the panel for each of you, one in a row. So could you please just very briefly state from your domain's perspective, what is the key challenge for this focus group? Again, from given your domain expertise, and how are we going to solve it? No, I start here.
Well, I think the number one challenge is going to be trust, and this has been actually the questions floated has been around all the discussions we have had. What level of trust will this focus group be able to inspire and as a consequence reassure the users of the benchmarks and reassure the ones who provide their own data, which means ultimately the patients and the citizens.
And how and the solution? Ask to state the problem and the solution.
The solution, you heard my talk.
Okay.
So main challenges and solutions. I think from legal perspective is that, this is an ambitious initiative and we're dealing with very new technologies on international level. So the kind of challenge is to operate in a multi-jurisdictional environment with laws which haven't necessarily foreseen this type of initiative and kind of interpret them in the best case in a kind of proactive and positive manner that this can be done and we can have a benchmark for these technologies.
From my very own perspective,
yes.
Again, I think we need to establish metrics and benchmarks for measuring security, in this case, security and privacy. And how can this be achieved? Well, there is plenty of work likely doing so. I mentioned some of it in my talk, but I think there is plenty more. I think it's a matter of deciding what is the scope we want to protect, and then how we can measure that we are actually successful in doing so.
I first would like to say that I really, really like the idea and the project. It's ambitious, but I think you've also shown the importance. And for me, it would be to understand the relevance of your project in the sense that if you look at it from ethical, legal, and social perspectives, I think there is much more to it, much more to be gained, but there could be also much more problems. And I think the solution to this challenge would be interdisciplinarity, and I think you invited us, so I'm very grateful for that. And I think, but to keep this alive, maybe also have people from other disciplines. I completely agree that computer scientists and doctors, physicians are the most important groups for this endeavor. But once in a while to listen to some other voices, maybe you could profit from that.
All right. Thanks very much. And please give a big round of applause for this great panel. And then we'll see each other in half an hour after coffee. Thank you.